NASA has looked deep into the universe with the James Webb Telescope and discovered things that shock even experienced astronomers. From mysterious pairs of objects in the Orion Nebula to signals that appear to travel faster than light. The discoveries made by the most powerful space telescope of all time are calling into question everything we thought we knew about the cosmos. Be sure to stay until the end, because today I'm taking you on a journey to the secrets of the universe. A warm welcome, everyone. If you stare long enough into the abyss also stares back at you, said Nietzsche, and this also applies to some extent to our gaze deep into the universe. Write to me and tell me what you think would be the most disturbing thing we could find in the universe. A technological signal moving rapidly toward Earth, a marauding black hole, or something else entirely. I'm very excited to hear your ideas.
And if you're as fascinated by astronomy as I am, then go ahead and subscribe to the channel right now. It doesn't cost any though. You won't miss any groundbreaking discoveries, and you'll be helping me out a lot. While you're at it, giving the video a thumbs up really helps. 5,000 likes is the magic threshold for the YouTube algorithm. Thanks everyone.
Our cosmic journey begins in one of the most spectacular star-forming regions of our galaxy. In the Orion Nebula, about 1,350 light years away from us, James Webb has discovered something that shouldn't actually exist. Mysterious pairs of objects float through the cosmos, each as large as Jupiter, but they do not orbit a star. These so-called jumbos present astronomers with a huge puzzle, because how do such gigantic objects arise in pairs in the middle of space without being bound to a star? But let's start at the beginning. The term jumbo refers to Jupiter-mass binary objects. These are strange objects with the mass of Jupiter that travel through space in pairs. This is exactly what the James Webb Telescope has discovered, and since then, the scientific world has been in turmoil. We already knew that there are free-flying planets known as rogue planets. These are worlds that were once part of a star system and were then ejected, for example, by a collision, and have since been traveling their lonely paths through the galaxy, far away from the gravity of a star. But such rogue planets are very difficult to detect, and as already mentioned, they are mostly loners. So what James Webb has now discovered somehow doesn't fit the picture at all. The jumbos appear in pairs, always, and James Webb has discovered 40 of these pairs. I don't know about you, but my first thought when I heard this was that they must be alien spaceships.
An idea that's as creepy as it is fascinating and absolutely not impossible, but not exactly what most astronomers consider the most likely explanation.
Some researchers have already taken a closer look at these things and found out a little bit about them. These objects were discovered in the Orion Nebula. According to initial research findings, the jumbos are about 1 million years old and their surface temperature is around 1,000 degrees. Their age is truly remarkable, as it is incredibly young compared to the rest of the universe. Our galaxy is over 12 billion years old, our solar system 4 to 5 billion, and these jumbos are only 1 million years old. Their surface is hot, as if some kind of artificial energy process were taking place inside them. However, astronomers believe that unlike normal planets, which can maintain constant temperatures thanks to the energy they receive from their stars, the jumbos cool down and freeze relatively quickly, and they also consist largely of gas, which means that they are probably not capable of supporting life. But what are these things then? Good question. At present, we can only speculate, and researchers currently favor two hypotheses. The first is that the jumbos were formed in areas of the Orion Nebula that were too thin to produce real stars. There was not enough hydrogen for a star to form and nuclear fusion to ignite, and so a brigade of failed stars was created. Too big for a gas planet, too small for a star. The second hypothesis is that they were formed as normal Jupiter-like gas planets that were supposed to orbit stars, but were ejected for unknown reasons. Professor Mark McCaughrean, Senior Advisor for Science and Exploration at ESA, says, "The ejection hypothesis is the preferred one. Gas physics suggests that objects with the mass of Jupiter cannot form on their own, and we know that individual planets can be ejected from star systems. But how do you eject pairs of these things together? At the moment, we don't have an answer. That's a question for the theorists."
To be honest, I don't find it very convincing that it would happen even once that a pair gets ejected from a planet somewhere. That alone would already be unlikely. But here we're talking about at least 40 pairs. Supposedly, all of them were ejected from their systems in pairs in the same region, all with a similar structure and mass. I just can't believe in that much coincidence, I have to say. And other astronomers also openly admit that, basically, we have absolutely no idea what this could be. Dr. Ed Bloomer, for example, an astronomer at the Royal Observatory Greenwich, says,
"This suggests that our existing models and explanations for the formation and evolution of planets are not as complete as we would like them to be, and I don't think any astronomer would claim that we have already explained everything in this area of astrophysics. We may be seeing something completely new that no one has ever seen before. The Orion Nebula is a very special environment, quite different from the neighborhood around our solar system. There are dense clouds of hydrogen and young hot stars that have just formed. Who knows what is possible there? I tend to think that we are actually seeing something new in planet formation that we did not know about before. Until now, it was assumed that planets usually form in an environment where a star is present to shape them. The existence of jumbos that exist without such a star could point to an unknown process in planet formation. Perhaps the Orion Nebula is not only a star factory, but also a jumbo factory, and in certain parts the hydrogen density is distributed in such a way that it is never quite enough for a real star, but always enough for two gas planet-like spheres that are then gravitationally bound to each other forever. I would be very interested to hear what you think. What is the deal with the jumbos? How are these objects formed? Write your explanations in the comments, and maybe we can get an exciting discussion going and solve the mystery together. From mysterious objects, we now turn to a physical discovery of the highest order. James Webb has observed signals that appear to travel faster than light. Does this disprove Einstein? What exactly did the James Webb Telescope discover? These are wave patterns that spread around the supernova remnant Cassiopeia A, and measurements show that these waves race through the cosmos at a speed faster than the speed of light. Astronomers call such phenomena superluminal. Do the laws of nature suddenly no longer apply? What we are observing here is a so-called light echo. To understand how this works, imagine the following. A supernova occurs, meaning a gigantic star has reached the end of its fusion and releases an unimaginable amount of energy in the process. This event causes a sphere of light to spread out, which of course moves through space at the speed of light. So far, so normal. Now imagine that behind this supernova, there's a cloud of dust, basically a flat plane of cosmic dust. When the expanding sphere of light hits this dust, it reflects the light, and we suddenly see a glowing ring. The exciting question now is, at what speed does this ring move outward? And is the speed of light really refracted in the process? This is where it gets really exciting mathematically, because the answer depends on the angle at which the ball of light hits the dust cloud. At first contact, this angle is virtually zero, and the speed at which the ring spreads is theoretically infinite at that moment. You heard right, infinitely fast. So we see a ring that initially races outward faster than light and then slows down. And that is exactly what a light echo is. It is not that the dust moves faster than light, nor is it that the light itself moves faster. What moves faster than light is merely the point of intersection between the light sphere and the dust cloud. This is not a physical object, but a geometric phenomenon. Based on this, some physicists believe that true superluminal velocity is real. Cassiopeia A is not the only example of such superluminal observations in astrophysics. Very close to the center of our Milky Way, researchers have tracked X-ray echoes from eruptions of the supermassive black hole Sagittarius A Stern. These echoes also appear to move faster than light across molecular clouds in the surrounding area. A team of researchers was able to reconstruct the 3D distribution of these clouds and even map their internal structure. And then there is the galaxy Centaurus A. There, astronomers have observed a jet of matter ejected from a supermassive black hole. And this jet appears to be moving at 2.7 times the speed of light.
Here too, it's a kind of optical illusion that arises due to the geometry of observation. When an object moves almost directly toward us and approaches the speed of light, it can appear as if it is exceeding the speed of light. This is because the light emitted by the object at different times reaches us almost simultaneously, which leads to this astonishing illusion. So far, so good. Those were all examples of apparent faster than light motion. But now it gets really interesting, because I want to talk to you about the question that probably brought most of you here. Could faster than light travel ever be real? Not just apparently, but in the sense of actually transmitting information faster than light.
Physics does indeed have a few doors that are open, at least mathematically. One particularly fascinating example concerns quantum mechanics. The reason why quantum mechanics does not allow information to be transmitted faster than light depends entirely on the probabilistic interpretation of quantum physics. The following can be proven mathematically. If there were even the slightest deviation from these probabilistic predictions, it could be used to transmit information faster than light. Most physicists interpret this to mean that nature is fundamentally random in the quantum mechanical sense, and that it is precisely this randomness that protects the speed of light limit. However, there is one exception, and that is physicist Anthony Valentini. He believes that the quantum randomness we observe is only a good approximation, but is not always correct. In one of his published studies, Valentini writes, if quantum mechanics is only an approximation of a deeper theory, there may be situations in which information can propagate faster than light. This is a completely unexplored but extremely exciting idea. Incidentally, superluminal velocity also appears in many attempts to modify gravity, that is, in theories that attempt to explain dark matter. When you play around with these theories, you basically always end up with some form of superluminal propagation. Most physicists take this as a sign that something is wrong with these theories, but I sometimes wonder if perhaps mathematics is trying to tell us something and we should take superluminal velocity more seriously. In quantum physics, this actually seems to be forbidden, but some researchers, such as Anthony Valentini, believe that there could be a deeper theory in which this limit is not absolute, perhaps opening a small window to true superluminal velocity. And then there is Einstein's general theory of relativity itself, which actually allows certain types of cheated superluminal velocity, wormholes for example. You don't actually travel faster than light through the wormhole, but you arrive at your destination faster than light that has not traveled through the wormhole. While you cannot move faster than light in space-time itself can move faster than light. Physicists believe that this happened in the early universe, that space expanded faster than light. Mathematically, this would even make warp drives possible. However, and this is a big however, we do not yet know how to actually create and maintain wormholes. This seems to require negative energy, but we have no idea how to generate enough of it. The observations of the James Webb Telescope are absolutely real and super spectacular, but they do not violate the laws of physics. Light echoes such as those around Cassiopeia A are incredibly useful for astrophysics because they help us understand the three-dimensional structure of cosmic dust clouds. True faster-than-light speed in the sense of information transmission remains science fiction for now, but physics leaves a few loopholes open.
Now things are getting really crazy. Scientists have developed a theory that sounds so spectacular, you could easily mistake it for science fiction. Dark stars. These giants would be larger than our entire solar system and shine brighter than an entire galaxy. But unlike normal stars, they are not powered by nuclear fusion, but by dark matter. The James Webb Telescope has now actually found evidence of these bizarre objects.
Imagine looking up at the night sky and seeing something that, according to all the laws of physics, shouldn't actually exist. That's exactly what happened to astrophysicists, and it calls into question everything we think we know about the origin of the universe. We're talking about so-called dark stars, and before you think that's a contradiction in terms, let me explain why this discovery is so revolutionary, because these stars are actually anything but dark. They are so bright that they can outshine entire galaxies. But first things first, the problem that has preoccupied scientists for decades is supermassive black holes. These cosmic monsters are found at the center of virtually every galaxy and have a mass of millions to billions of suns, but no one knows how they were formed. A normal black hole is formed when a massive star collapses at the end of its life. But supermassive black holes are so gigantic that their formation can hardly be explained by normal physical processes. Where could so much mass come from, and how could it compress itself so much? This is where dark stars come into play. These hypothetical objects could be the answer to this cosmic mystery, and they are as terrifying as they are fascinating. And to understand dark stars, we need dark matter. This invisible substance makes up about 27% of the universe, more than 5 times as much as normal matter, and although we are relatively certain that it exists, we have no idea what it is made of. One of the leading theories suggests that dark matter consists of WIMPs, which stands for weakly interacting massive particles. These particles hardly interact with normal matter, but they can collide with each other and destroy each other in the process, releasing enormous amounts of energy. When enough WIMPs come together in one place and annihilate each other, something unimaginable is created. A star that does not burn through nuclear fusion like our sun, but through the pure annihilation of dark matter. That is why they are called dark stars, not because they are dark, but because they are made of dark matter, and these stars could become incredibly large. large. While normal stars are compressed by their own gravity and are therefore limited in size, dark stars could theoretically have reached the size of our entire solar system. Dr. Catherine Fries of the University of Texas, one of the leading researchers in the field, explains it this way. Dark stars would not need to be compressed as much to ignite. They could burn stably at much larger diameters because they don't rely on nuclear fusion, but on the mutual annihilation of dark matter particles. But that's not the most frightening thing about them. The frightening thing is their unimaginable brightness. When WIMPs collide and annihilate each other, they produce even more light than nuclear fusion. A single dark star would theoretically have shone brighter than an entire galaxy with billions of normal stars. And now comes the really exciting part. We may have already found such dark stars. The James Webb Space Telescope discovered something strange during its observations of the earliest period after the Big Bang. It found galaxies that were far too bright and existed far too early to be possible according to our current models. One of these surprising galaxies was dated to only 302 million years after the Big Bang. In cosmic terms, that's like finding a toddler who already has a doctorate. When Dr. Fries and her team analyzed these images, they came to a startling conclusion. What we see here may not be galaxies at all, but the first dark stars ever captured by a telescope. 3 of the mysterious objects discovered by James Webb shortly after the Big Bang all have a characteristic round shape and lack the typical spiral structures of normal galaxies. They are estimated to be 1,000,000 times more massive than our Sun. Exactly what you would expect from a dark star, but how can we even see something made of dark matter? Even though the WIMPs themselves are invisible, the energy released when they are destroyed heats the surrounding normal gas so much that it begins to glow. But the really scary thing is what happens when such a dark star has used up its fuel. Because when all the WIMPs inside it are destroyed, it collapses under its own enormous mass and becomes a supermassive black hole. And here we come full circle. This dark star could be the long-sought explanation for how the supermassive black holes at the centers of galaxies were formed. If dark stars really existed, they could have collapsed directly into supermassive black holes without having to go through the intermediate steps that are normally necessary, summarizes Dr. Cosmin Ailey of Colgate University. But what if dark stars can still form today? Some scientists believe that dark stars can still be born today in regions with extremely high concentrations of dark matter, such as in the centers of galaxies. In fact, there is a region in our own Milky Way that looks suspicious. The so-called S cluster, located directly around the supermassive black hole at the center of our galaxy. An unusually large number of young stars are found here, even though the extreme conditions near a black hole should actually prevent star formation. Could it be that we are witnessing the birth of new dark stars without knowing it? If so, it shows us how little we really know about our own cosmic home. Research on dark stars is still in its infancy. Further observations with the James Webb Telescope should provide more clarity in the coming years.
The boundaries of our knowledge are being redefined every day. If you haven't subscribed yet, now's the perfect time to become part of this astronomical journey. Click the subscribe button and don't forget to give us a thumbs up so we can reach 5,000 likes. And while we're on the topic of spectacular discoveries, les limites de notre savoir sont redéfinies chaque jour. Si vous n'êtes pas encore abonné, c'est le moment idéal pour rejoindre ce voyage astronomique. Cliquez sur le bouton d'abonnement et n'oubliez pas le pouce en l'air pour qu'on atteigne les 5000 likes. Et puisque nous parlons de découvertes spectaculaires,
I recently visited one of the most fascinating places on Earth, CERN in Switzerland. There I visited the antimatter factory and delved into the deepest secrets of the cosmos. In the video above right, I show you what antimatter is all about, how the scientists there are literally investigating the building blocks of reality, and what incredible experiments are being carried out in the world's largest particle accelerator. It's very exciting, and for anyone who wants a galactic Astro Tim shirt or a plush planet, check out my space shop at the bottom left. Every order really supports my work. Otherwise, I'd say see you in the next video. Take care, everyone.